Welcome to today's Explainer. Today, we're diving into something absolutely wild. We are looking at what actually happens when you hand over complete end-to-end management of a physical data center to an AI agent. We're talking absolute control of bare metal, operating systems, and web services, all handed over to an AI named Alex. Imagine having a sysadmin that literally never sleeps, doesn't get bored debugging at 2 in the morning, and can manage everything from a physical hard disk failure right up to the exact words published on a web page. It's a completely different way of thinking about IT infrastructure. The source material we're digging into today gives us a brilliant ground-level look at what really goes down when you let the AI completely take the wheel.
Okay, let's just jump right in. To really grasp this experiment, you kind of have to understand the sheer scale of the setup. This isn't just some tiny simulated sandbox. No, this is a fully functional data center literally sitting in a spare bedroom. We are talking about a fleet of 24 distinct machines. That fleet is running 5 different operating systems, which includes 2 hypervisors and a dedicated storage array. And if that wasn't enough, it's hosting 17 containers, 7 live WordPress sites, and yeah, even a blockchain node. Traditionally, keeping an environment this dense humming along is a massive headache for a human operator. You're constantly monitoring hardware, patching OSs, keeping sites live. It's a lot. But what happens when you just, stop managing it yourself?
To find out, the operator decided to start with the ultimate stress test. They hit the AI with the sysadmin's absolute worst nightmare, a major, irreversible OS upgrade. This isn't just a quick security patch. This is the big one, where a machine fundamentally swaps out its own foundations while actively running on them. Historically, doing this across 3 servers is a Saturday you are absolutely never getting back. But with Alex managing the data center, the operator literally just typed a single sentence into a prompt. They wrote, "Upgrade these 3 servers and don't wake me up." Talk about putting a crazy amount of trust in a text box.
Now here's where it gets super interesting. Let's look at the AI's logic right before it actually executed that command. It implemented the strict snapshot gate. Before Alex touched anything irreversible, it stopped. It proactively went all the way down to the hypervisor level, took a complete snapshot of that exact machine, and then, and this is crucial, it waited for hard proof that the snapshot actually existed. It didn't just fire off a backup command and cross its digital fingers. It demanded evidence. And really, that's the line between a manageable risk and a total catastrophe, right? Everything before that snapshot can be undone. Everything after it cannot. The AI absolutely refused to cross that line on just a promise.
Once it proved that safety net was in place, the AI ran the dangerous part of the upgrade entirely as a detached job. This is so smart because, of course, when the operator's Wi-Fi inevitably dropped, the upgrade just kept on rolling without them. Alex autonomously managed the whole sequence. It initiated reboots, waited patiently for the network to come back up, and rigorously checked that every single service was running correctly. The end results? 3 servers perfectly upgraded to Debian 13. It took 2 hours, required 0 additional prompts from the human, and honestly, the only way the operator even knew it was done was a simple summary email pinging on their phone.
And this end-to-end management doesn't just stop at routine maintenance. It's a huge deal for active security too. So the data center's web server was running a pretty standard security tool called fail-to-ban. It had 6 specific rules to block brute force logins, and the operator thought they were totally locked down. But Alex actually caught 2 malicious bots hammering the login page that fail-to-ban completely missed. And this wasn't a bug in the tool. It was a blind spot. The traditional rule was strictly looking for failed login attempts. But these specific bots, they were knocking on slightly the wrong door, which made the server redirect them before WordPress even realized they were trying to log in. They were hiding where nobody was looking. It just goes to show that the AI isn't just running through a checklist, it's actually looking at the context.
Because Alex can actually read the raw server logs and apply logic, rather than just blindly following rigid rules. It spotted the pattern instantly. It realized the bots weren't hacking the detection. They were just standing in the shadows. So the AI figured out the exact problem and applied a fix. And the precision here is just incredible. To patch this invisible vulnerability and permanently block those bots, the AI literally just changed 3 specific characters in the filter. 3 characters. It didn't nuke the whole security system or cause any downtime. It just found the exact logical gap and sealed it.
Let's zoom out a bit, because there's a fantastic metaphor in the source material to explain why this AI management is so powerful. They call it the stairwell. So think of your traditional IT tools as living on just one floor of a building. You've got one tool on the hypervisor floor, one on the server floor, one for backups, one for websites. But the nastiest, most complex problems, they don't live neatly on one floor. They live in the stairwells between them. They're cross-stack issues. Traditional tools are totally blind to the stairwells. But an AI agent like Alex, it has the keys to the entire building. It can climb the whole thing.
And we see concrete proof of this cross-stack magic all over the source material. Because it has that full end-to-end access, the AI can read physical disk health deep inside the hypervisors. Like, it flagged a storage drive with 47 reallocated sectors. The drive wasn't dead yet, but the AI flagged it as a hardware trend to watch on every future audit. Plus, it can bounce between managing Linux and Windows operating systems in the exact same conversation. It even chewed through 61,000 lines of router logs in just 90 seconds. It instantly filtered out all the noise to tell the operator which scary-looking numbers were actually perfectly fine.
But here's where that stairwell metaphor really pays off. The AI grabbed the hypervisor's master list of machines and it held it right up against the backup server's active jobs list. Instantly, the gaps lit up red. 2 completely healthy machines had silently dropped out of the automated backups months ago. From the server floor, they looked perfectly fine. From the backup floor, they literally didn't exist, so no alerts ever went off. They were totally invisible from either floor, but completely obvious to an AI standing in the stairwell.
Okay, so we've seen how insanely good this AI is at playing defense and doing maintenance. But what happens when we ask it to actually create something? The operator tested this by tossing it a really simple creative prompt: build me a website. And to be super clear here, the goal wasn't to just spin up some generic template stuff with placeholder text. The requirement was a fully functional, actual live site with customized pages, proper structure, and real navigation.
And the crazy part isn't just the speed. Though honestly, going from 0 to a live site in minutes instead of a whole weekend is pretty amazing. The real magic is the multi-layered execution. To build this from scratch, the AI wrote content that actually sounded human. It generated custom imagery to fit the vibe, it built the page structure, configured the WordPress theme, wired up the SEO descriptions, and finally deployed the whole shebang onto a real web server with a valid SSL certificate. If you've ever built a site, you know that usually means wrestling with 4 different software tools and giving up 3 afternoons of your life. The AI handled the entire stack in minutes.
This capability gets even wilder when you apply it to really tedious e-commerce stuff. Adding a product to an online shop is just notoriously frustrating, right? You usually have to fill out like 20 different fields across 6 panels, titles, categories, inventory, always with that sinking feeling you forgot a crucial setting. But with this AI in charge, the new workflow is almost ridiculously streamlined. The operator just supplies 1 photo, 1 price, and 2 simple lines of text describing the item. That's literally it. The AI takes those 3 basic inputs, writes a compelling description in the shop-specific voice, categorizes it, attaches the image, and automatically handles all the complex background tasks like setting up the stock tracking perfectly.
The result is a gorgeous, fully finished, professional product page generated almost instantly from just a photo, a price, and 2 lines of text. It totally removes the friction of running an online storefront. Actually, it's pretty funny. When the operator showed this lightning-fast workflow to their wife, her immediate, very practical reaction was simply, well, can it do the other 40? Because when you eliminate all that heavy lifting, suddenly scaling your output doesn't seem so impossible.
Now, I know this is all starting to sound a bit like magic, so let's hit the brakes for a second. We really need to ground this explainer in reality, because if we just stopped here, this would sound like a theoretical sales pitch. We have to ask the really critical question: what actually happens when the AI makes a mistake? Because let's be real, it's an AI. Eventually, it's going to miscalculate. What happens when you've handed an autonomous agent the keys to your entire data center, and it genuinely messes up?
Well, the source material gives us a perfect, honestly terrifying example. The AI was running a routine cleanup on the server, just doing its thing. But during the process, it decided to remove a specific software package. What it didn't realize was that removing this one package triggers a massive cascading effect that deletes every single SSL certificate on the server on its way out. So boom, all 9 certificates, the ones providing secure connections for all 7 live websites, were instantly wiped out. The sites didn't break that exact second, but the very next time that server rebooted, it was going to be a total chaotic disaster for the operator. But here is exactly why that end-to-end architecture matters so much. The AI caught its own mistake almost immediately. It realized the certificates were gone, pinged the human operator right away to alert them, and then autonomously restored the server from the hypervisor backup it had intelligently taken right before starting the cleanup. So the actual damage? Absolutely 0. But the lesson learned? Permanent.
That single incident fundamentally changed how the operator manages the AI. It proved that while the AI is incredibly capable of doing the tireless, complex heavy lifting, analyzing the stack across every floor and queuing up the necessary work, human oversight is still absolutely mandatory. Now, before the AI changes anything in the data center, it tells the operator exactly what it plans to do, and then it waits. The operator has to physically press an approval button. It's this perfect balance between the insane power of AI automation and the essential safety of human judgment.
So we come all the way back to the spare bedroom data center. 24 machines, complete control over every single layer, from the bare metal hard drives all the way up to the web pages, all managed through one simple text box. The heavy lifting is completely outsourced. Those sneaky cross-stack problems are illuminated, and the creative friction is just gone, all safely guarded by an approval button. It completely redefines what a single human being can realistically manage. Which leaves us with one final thought to take away from all this today. If you had an AI agent with the keys to your entire infrastructure, what would you point it at first?